Alright folks, in this video we are going to look at some blood spatter calculations. Now we've previously learned about the different types of blood spatter and what could have caused them, but now we're actually going to look at some numbers and we're going to do a couple of calculations. First thing we want to discuss though is the direction of impact. So you can figure out the direction that the blood was traveling by looking at the shape of the drop. The distorted or disrupted edge of an elongated stain indicates the direction the blood came from. The pointed end of the blood stain is called the tail. The tail will always point in the direction of travel. Satellite spatter around parent stains will have the pointed end facing the direction of travel as well. So here we can take a look at our blood drop on the left-hand picture. And we can see at the bottom the tail, and that helps us to indicate the direction of travel. So it was coming downwards, okay? That's where the blood came from. Okay, now that's simple enough with one drop, but of course when you go to a crime scene, you more than likely are going to have lots and lots of these blood drops. Next thing we're going to look at is the angle of impact. So when a droplet of blood strikes a perpendicular surface, meaning a 90-degree angle, the resulting blood stain will be circular. That being the length and the width of the stain will be equal. They'll be the same number, and there will be no tail and no buildup. So if we're dropping it from a 90-degree angle, that means we're dropping it from straight above. Now, blood that strikes the surface at an angle less than 90 degrees will be elongated, or it'll have a teardrop shape, and blood that strikes the surface at more than 90 degrees will have more buildup of blood. So on the picture on the left, we can see a blood drop that was dropped at an angle at 90 degrees. Okay, you can see that the length and the width of the drop is equal, and it's perfectly circular. On the right-hand side, we see that the blood drops have varied angles, and it is not perfectly circular. And you can see some of the buildup of the blood. Now, as we can see, determining the angle is the question. Okay, how do we actually figure out what angle it dropped at? So we're going to calculate the angle of impact. So the angle of impact is the acute angle formed between the direction of the blood drop and the plane of the surface it strikes. We can use a trigonometric formula to determine the angle of impact. And the formula that you need to know is the arc sine. Okay, arc sine is sine to the -1 of some angle A equals the width of the blood stain divided by the length of the blood stain. So here we can see our blood drop. We can measure the width going across, and then we have our length of our blood drop. Okay, we're going to measure the width and the length. We're going to divide the two numbers, and then using a scientific calculator, we're going to calculate the arc sine, and that will give us our angle. So let's take a look at an example. So here we have a blood drop. The length was measured to be 22 millimeters long, and the width was 11 millimeters. So if you remember, here is the formula that you need to use. We're going to plug in 11 as the width and divide it by 22. So 11 divided by 22 is 0.55, or 0.5, excuse me. And then using a scientific calculator, we're going to calculate the arc sine, or the inverse sine, of 0.5. So we would go to our calculator and input arc sine or inverse sine of 0.5. And when you put that in the calculator, you would see that you get an answer of 30, meaning this blood drop came from an angle of 30 degrees. Okay, pay close attention to this example. This is what you're going to be doing on the practice worksheet. The next thing I want to talk about is the point of origin and convergence. So the point of convergence is the common point on a two-dimensional surface from which the drops originated. So the point of convergence can be found by drawing a straight line through the long axis of several individual bloodstains following the line of their tails. And then the intersection of these lines is the area of convergence. So we can see on the right-hand picture, we have the blood drop, and you can see that where the long axis is along the length of it. So we draw the line. And then when we have multiple blood drops, we draw multiple lines, and you can see that they're all converging at one spot. They might not all cross at one specific spot, but they're all coming to a certain area or certain point. So that circled area at the bottom is your area of convergence. So the area of origin is the three-dimensional space from which the blood was projected. Previously, we looked at 2D, just flat, but things occur in three-dimensional space. So this will help show the position of the victim or suspect in space when the stain-producing event took place. In general, impact stains that are close to the source of the blood will appear clustered, and impact stains that are far away from the source of the blood will appear far apart. So now, by calculating the angle and looking at where the blood originated from, we can see where was the victim when they were attacked, or if the victim was bleeding or the suspect was bleeding and they were producing blood and there were blood drops left over, we could figure out where were they when the attack happened. And one of the last things we can talk about is the string method to determine area of origin. Okay, if you've ever seen Dexter, you know he is a blood stain pattern analyst. His job is to look at blood, and he uses this method to determine the area of origin. So first you find the area of convergence for the stain pattern. You place a pole or a stand as an axis coming from the area of convergence. You would attach one end of a string next to each droplet. You would then place a protractor next to each droplet and lift the string until it lines up with the determined angle of impact. And then, keeping the string in line with the angle, you would attach the other end of the string to the axis pole. You would view the area of origin of the drops where the strings appear to meet, and then you would secure the strings at this area. So we can see in the picture where there are these blood drops on the wall or the ground, and then you attach these strings at the appropriate angle that you calculate, and they would all come up at one point, and this would be where your victim or suspect was standing, or if they were moving, or if there were multiple people involved. This would help determine that.